Ovarian longevity is a subject that directly affects 50% of the world's population, but it's a subject that touches everyone: husbands, sons, researchers, investors, healthcare providers, as well as health policy developers. Now, ovarian aging is the natural decline in the quality and quantity of eggs, oocytes, that eventually results in infertility and menopause. Now, interestingly, ovaries are one of the earliest aging organs, and ovarian aging is considered to be the pacemaker of female body aging, as it drives the aging of multiple organs in the body. Now, the majority of female mammals stop producing eggs long before the end of their potential lifespans, but in the wild, few reach this point, but other than humans and some whales. Now, ovarian longevity has the potential to delay menopause, to better align with the increasing health span of women, to consequently increase the size of the childbearing window and improve fertility rates. And with birth rates dropping in most developed societies and the future demographic time bomb of countries having increased elderly populations and the eroding tax base of fewer babies coming through the pipeline, ovarian longevity is a subject that's really attracting a lot of scientific and investor interest. And to discuss this super important subject, I'm joined today by Dr. Stasa Stankovic, who's a reproductive geneticist at the University of Cambridge in the UK, and Martin Varsavsky, who is founder and chairman of Overture and Prelude Fertility, and he's also the chairman of Gameto. So, guys, thanks very much and great for joining us today.
Thank you so much.
Cool. And Martin, if I could maybe just start with you. You know, the buzzwords associated with this space are everywhere, and fertility preservation is a market that's predicted to reach nearly 48 billion by 2030. But your interests are much wider. So, what got you into this space in the first place? Was it a passion or a technology, or perhaps a combination of the two?
Well, in my, let's say, university studies, I was a pre-med student and I thought I was going to be a doctor. And then my father died very early and we found ourselves as a struggling family, and I switched towards becoming an entrepreneur. And I was an entrepreneur. I built, over 30 years, I built 4 unicorns in spaces that had nothing to do with medicine. These were telecoms, renewable energy, consumer internet. But then I always had this calling for medicine coming back, and it coincided with me being a patient, a fertility patient. So when my wife and I had trouble conceiving around 15 years ago, I started studying again, you know, what sort of refreshing my knowledge on biology, human biology and genetics, and because I always have this academic approach. My dad was an astrophysicist, a PhD from Harvard, and my uncle was a mathematician, and I always grew up in this, if you have a problem, study it, right? That was kind of for how I grew up. So I started trying to understand, why is it that we can't have children? And all this was maybe at waiting rooms in fertility clinics. And that's where I became very interested in this field as a wannabe dad. And then it worked very well. We got 3 children out of IVF, and the youngest with fertility preservation, with genetically tested embryos, with like the whole program, right? And then I became very enthusiastic about this, obviously, as the result of growing my own family. And I left what I was doing in renewable energy and what I was doing in well, mainly in renewable energy, or I, let's say, left it to the side. That company still grew, and we sold it for 1.1 billion. So the company was a success, but I became obsessed with fertility. And yes, and since then, since 2015, 16, I've been building fertility companies. Prelude, or Inception, is the corporation. Prelude, the clinic, which is the largest provider in North America, fertility services, IVF, egg freezing, and then Overture, which has fertility equipment, and Gameto, fertility medication, and Vitara, which is involved with the artificial uterus. That I'm not the founder of that company, but I'm quite involved. So I became very involved in this, and it's the most satisfying thing I've ever done. It's been 150,000 babies being born by now, and I'm all in this field.
Well, that's wonderful. And I guess, Stasa, you're really at the front line of the science side of things. Martin's there representing some great insights on the investment and passion side of things. But what do you feel are the main challenges and pain points in the field, and what inspired you to get involved in the first place?
Well, I think Martin gave an excellent foundation for what I was trying to say. When you don't have knowledge, you don't have an ability to innovate. And women's health is a specific area which was underfunded and understudied and under everything for a very long time. I like to say it was under this veil of taboo for decades. And, if you don't understand the basic biological mechanisms that are driving certain disease in the first place, you're not able to come up with solutions. And that's why today a lot of the women's health related as well as reproductive related solutions are actually treating just symptoms or masking them slightly, but we have a very few hardcore technologies that are going deep into the root cause of a disease. And this is where science can happen. And unfortunately for women's health and especially female reproductive health, drug discovery pipeline has been broken for a very long time.
Okay.
The first reason is we don't have data. There was no data collection around women and around their reproductive health. And you wouldn't just do random biopsies of ovaries to figure out what are the biological drivers to make them function better or worse, or age quicker or less quick. And then on the other side, the current models, like, for example, animal models, mice, their biology doesn't very well represent the female reproductive system. So even if we had a good therapeutic target, we didn't have good models to mimic that female reproductive biology reliably to figure out whether those therapeutics were doing what we want them to do. And this is where genetics was extremely revolutionary, because for the very first time, we kind of got a data set, a large scale data set of over 500,000 women in our case, where we could really dig deep into what are those genetic secrets, what are those parts of DNA that make one woman less or more fertile, that make one woman more or less predisposed to diseases like polycystic ovarian syndrome, miscarriage, or anything else that relates to reproductive function. And this is where at the University of Cambridge, we're really at the front seat, at the driver's seat, to figure out and crack the genetic code behind all these traits, and so far doing it very successfully. And this is leading us now to some very interesting targets, and both on the kind of diagnostic space as well as therapeutic, that I'm sure we will be discussing with Martin and you today.
Yeah, sure. Well, I guess first a question in relation to those samples. Where did you receive those samples? Was it like biobank data, or how did you obtain them in the first place?
Exactly. Some of the countries, including United Kingdom, is doing an incredible job in collecting samples, both on the genetic side as well as on the, as we call it, phenotype side, meaning things from your kind of blood biomarkers to MRI scans, all the way to how many times you watch the television. So
Oh, wow. So you've got
it's incredible.
quite a lot of
Yes.
data points there. Well, of
Yeah.
course, the transition to menopause is associated with increased risks of cardiovascular disease, osteoporosis, even cognitive decline and dementia. But there's a lot of different terminology flying around in this space at the moment. And I feel it would be very helpful to ground the conversation in what it is that we're really talking about. Are we delaying menopause to increase the window of extended fertility? And therefore, that it's a discussion about birth and fertility rates, or are we talking about longevity to help women with their longer term health, or are we talking about both, or is there a sequence to the way that you see the industry rolling out? Because it is very confusing for everybody, I feel, and I guess that people are doing lots of different things, but the industry is still relatively small, isn't it? So I'd be very, very open to how you guys would define it at the moment.
Well, in the case of Gamito, which I co-founded with Dr. Dina Radenkovic, similar name to Stasa, but Radenkovic, Dina and I have been working, the whole team at Gamito. This is a company we have raised so far $73 million for, and recently another 10 million exclusively for menopause. The issue with ovarian aging is that ovarian aging affects both fertility and menopause. Inside Gamito, this is divided into two projects. One is called Fertilo, and it's about having babies, and the other one is called Amino, like no menopause, and that one is about delaying menopause, right? And the technology behind both products is the same, is artificial ovaries, and how can you use artificial ovaries in both cases. So in the case of Fertilo, what we do is we create these artificial ovaries using induced pluripotent stem cells, and we then do a very short stimulation, not 2 weeks of stimulation as it's done now at the Prelude clinics, in order to get eggs and then to do fertility preservation or IVF, because the process is the same. It's the social decision that is made by the patient. A patient who freezes eggs and a patient who does IVF go through exactly the same thing.
And Martin, can I just ask you, how valid are those? I mean, are they presumably, it sounds like a very straightforward process that you just laid out there, but actually when you conceptually go back to that, that's pretty amazing, right? So scientifically and technically, are they valid as eggs?
If I understand the question correctly, let's say whether you do IVF or whether you do fertility preservation, you start with a 2-week stimulation process of using gonadotropins, and it's one of those situations that if you didn't tell the doctor what you're doing, the doctor couldn't tell, because the process is the same, right? But then the decision made by the patients of what to do with those eggs, fertilize them, make embryos, or store them for 10 years, it's the patient's decision. It is interesting, and this may be a digression, but a lot of what happens in IVF is medical and scientific, but it is also social, meaning it's the decision of the patient. What do they want to do? Or to give you a surprising piece of data, you can use services like 23andMe and find out that you're 3% Polish, but you cannot use 23andMe and find out that you're an IVF baby. Meaning
Right.
that people conceive with IVF have no markers. So the whole IVF industry, which is surprising, is based on parental testimonials. They have to tell you they had the baby with IVF because nobody has developed a test that says, oh, this grown-up is an IVF baby, or this grown-up was conceived naturally, right? So a lot of these things are medically the same, but then with there's a social destination that is different. And in both products, the idea is to use these artificial ovaries, but in very different ways. In one, it's used to only stimulate for 3 days and then mature the eggs ex vivo in order to make egg freezing and IVF more convenient and affordable. In the other one, the process is completely different, and it's about implants of newly made ovarian cells that would signal to the body that the person is not 48, that this is a much younger person. And then the objective is, let's say you mentioned osteoporosis. The objective is osteoporosis, let's say, starts at 50. Why not make it start at 60? In the end, the idea is to give women more health span, right? Maybe the lifespan is the same, but who wants to live with osteoporosis, right? So it's kind of like living a better life. So delaying menopause is not exactly about having babies, because we're not trying to get that 50-year-old woman to have babies. It's about increasing health span.
Yeah, and Martin, just before I jump on to Stasa, so what is your favorite way of describing this or naming this? Is it reproductive longevity? Is it ovarian longevity? Because I believe the sector hasn't really settled on anything yet.
Yeah, I can only think of my wife who told me, no, first you fix my fertility, now fix my menopause.
Right.
So I mean, being a man, I listen to women, and I listen to my wife for sure, and her needs, my daughters, and I think in the end it's kind of this thing where it's the same organ that first gives you um, infertility and then menopause, but it's not the same symptoms, because it's not only about not being able to have babies. Because if not, you could say menopause is great because you don't have the period anymore, the cramps, sometimes people, especially men, say, so what is the purpose of delaying menopause if menopause, if the period is such an uncomfortable thing, what is it so great about needing tampons for longer and needing, but the result is not that, because if it was just that, one would say menopause is great. But I think if you ask women between 45 and 55, they would agree that menopause generally is not felt as a great thing.
Yeah, I mean, my wife's a case in point, but I guess Stasa, in relation to the naming of this area of science, have you settled on anything yourself?
I mean, I love the term reproductive aging, and I don't think it's about really setting the term. I think it's about educating women what menopause means and how does it happen. Because when you speak to the women who is not scientifically educated, not many of them understand what the hell happens with ovaries and why we enter the menopause. And maybe to start defining that would be an interesting task for now. So how I like to say it, and how it is scientifically defined, it's a natural phenomenon. It's a process that every woman goes through, and it leads to the decline in oocyte quality and quantity, so the number as well as the quality, until it reaches about thousands of eggs in the ovarian reserve when menopause happens. So each one of us is born with about 1 to 2 million of follicles in our body, and that number just goes down throughout life. Incredibly interesting. Unlike men, whose sperm is being regenerated and renewed on a daily basis, this doesn't happen in women. So the ovarian reserve is non-renewable. It just goes down. And what's incredibly important to say, Phil, just as a last comment, it doesn't happen at the same rate in everyone, and that's the trick. And the angle that we have to think about when we mention whether we are prolonging menopause for the sake of fertility or the health span, or both. Um, the average age is about 50, but there is 10% of women who are considered candidates or individuals with early menopause. That's menopause below 40, between 40 and 45. And then we have those extreme cases with premature ovarian insufficiency. That's menopause basically below 40. And what people don't understand is they usually think that when they enter menopause, that's when infertility kicks in. But actually, that's not true. About 10 years ago, about 10 years before menopause starts, that's when the fertility decline happens. So just imagine a woman who is, let's say, for example, menopausal at the age of 40. Let's not go to an extreme case. That means that her infertility will start kicking in at around age of 30. And now circle back that what Martin mentioned before with the social trend, when everyone wants to delay childbearing, when we want to have children at later age because we want to develop our career further, etc. That really clashes, and biology doesn't play this game with us. It goes against the social trend that's very kind of present at the moment. And that's the reason why we have to better understand menopause from the diagnostic perspective or predictive perspective. Can we find solutions to tell women at what age they will go through menopausal transition, so they can prepare if they know that they're early menopausal, so they can think about family planning way earlier than they thought they would. And then on the other side, it's that other category of women who are going through menopause at an average age, and how can we ensure better health span, what Martin was mentioning before.
Yeah,
So
yeah.
yeah.
So, I mean, I guess the thing is that obviously there are these two paths, right? So there's the ability to defer birth until later in life for career choices, and of course, as lifespans are extending, it's more having children at a midpoint in your life. But likewise, there's the concept of protecting your body through ovarian longevity, or whatever the term is that we settle on, that says, okay, I'm going to be pushing out the estrogen cliff and all the issues associated with these aging diseases. So because obviously we're a longevity channel, we're not so focused on the reproductive side of things. Maybe we should just keep our conversation moving towards the longevity agenda, because I feel that this is something that is very much misunderstood in the industry at the moment because of the confusion around the nomenclature. So what should we really say in terms of the effect of this technology now, and how it can be manifested through mitigation of those diseases, or at least pushing those diseases out? Is this something that you're actively seeing now in studies and maybe the work that you're both doing?
Well, in the case of there is an interesting finding that was done with based on girls who unfortunately had cancer when they were little and they were not menstruating, so they removed part of their ovaries and froze them, and there's been, I think, over 1,000 babies born out of this technique. These girls survived cancer, then went on to become moms thanks to the frozen ovaries. But then it was found that they had delayed menopause, right? Because they were getting the ovaries, like the clock was counting from the fact that it was frozen in time, because they were, let's say, 11, they got a piece of their ovaries, they got the ovaries back when they were 30, and then they were getting menopause considerably later, and that finding led to our idea that we should use induced pluripotent stem cells to make ovarian cells that when we can use in this process. Maybe a way to understand the reboot of aging that happens here is, think about a man who's let's say 38 and a woman who's 38. When they conceive a baby naturally, when they have sex and make a baby, the baby is not 38, right? And you're saying, how come the baby is not 38? Like, here's a 38 dad and 38-year-old mom, and the baby is 0, right? And so nature has made these rebooting mechanisms by which 2 38-year-olds can give birth to a 0-old baby, right? So, well, induced pluripotent stem cells, when they're made, they also reboot the signaling of their age. And so that's what we're working. And so what is the therapeutic objective of doing this? The therapeutic objective is delaying menopause, because as Stasa very well said, and I fully agree with her, is that the life of a woman especially has been, let's say, unfairly punished, or I don't know how to put it, but we're in a lifestyle in which we're asking women to study long careers, to work, and then their window to be fertile is so small, because before, let's say a woman at 16 is super fertile, right? Like teenagers, they look at each other, they get pregnant, right? And you say, why are we not having babies at 16? Well, because it basically destroys modern life to have babies at 16. And so we're pushing it to 36. But what is the window at 36? You're having your first child at 36, and already that's a geriatric pregnancy. And so we're trying to move women, help them to be in a box, a better place. And this is achieved both through fertility preservation, which is a technique that is not foolproof, but it works pretty well when women do it at 25, let's say, or before 30, and that helps a lot. There's also, of course, egg donation that helps a lot. I mean, at our clinics, it's easier to get a 48-year-old woman with donor eggs pregnant than a 38-year-old woman pregnant with her own eggs. it's interesting, but the eggs are like 90% of the problem here. And then the opportunity to make these ovarian cells that would make the body believe that that is younger, because for some reason we don't understand ovaries age so much sooner than the rest of the woman, and that's what we're trying to address.
Right.
Martin, I always love to say ovaries are at top of their career in their 20s, and we are in our 30s at the top of the career. So there is
Yeah.
some misplacement.
Well, what we say at Prelude is we try to couple the woman's biology with their psychology.
Yeah.
Yeah. So I guess the thing is that just exploring that a little further. So now you can control perhaps delaying the menopause, pushing it out maybe 10, 15 years beyond its natural cycle. Of course, it's very different for every woman. What are the knock-on effects of that? Are we seeing clinically now that later menopause? You mentioned earlier, Martin, that you've got some cases of that from these cancer patients. But are we seeing a direct line between healthy aging and delay of the menopause?
Who wants to go first?
Please, Stella, you go first.
I just want to maybe circle back to the previous question, which relates to this one. What Martin said, ovaries age, some people say 2 times faster than the rest of the body, the others say 5 times faster than the rest of the body. But what that means is that there is a single organ in our body that ages faster than everything else. And what does that mean in practice for the longevity or aging folks that you've mentioned? Is that ovarian aging is actually an amazing proxy for studying overall aging, because there are some mechanisms in ovaries that make it age faster, and we don't know why the hell that is happening. And
Right.
we know that there is a link. Obviously, there are mixed evidence about how well correlation is between ovarian aging and overall longevity of a woman. There are some studies that suggest an extremely well correlation. The other ones have not so well evidenced correlation, but I mean, there is something going on there that can help us figure out the clues of overall aging and cascade of events that happen after menopause. We know that women who are early menopausal are exposed to diseases like that you mentioned: osteoporosis, cardiovascular disorders, type 2 diabetes, different mental health disorders, etc. While on the other side of the party, there is later menopause, and then the link with reproductive cancers like breast cancer and ovarian cancer. So it seems that there is a balance, the fine balance of where menopause is and how then it impacts the health span, whether it's earlier or later. I have to say, we need more science and education to figure out what actually is going on there, to be able to make firm conclusions on whether moving menopause later on is completely safe, or if it isn't fully safe to be completely synced up with our overall aging. What is the limit where we can expose women to later menopause, but that it doesn't induce reproductive cancers that we've mentioned? And obviously, again, link with all these conditions have to be confirmed. And I have to mention genetics data that we play with do offer us that capability, because the DNA is the same. So we are just studying, are these genetic risk factors that are exposing women to late menopause also present in women with breast cancer, ovarian cancer, or other conditions that we are interested in? And then we are looking at the overlap. Are they together?
So you're starting to join up the dots and maybe see if there's a correlation between the two. So you mentioned genetics. So what is, how are gene therapies and innovations in this space progressing now? Is this something that we're seeing in the lab and moving into early clinical? I mean, what's the progress of it all?
So there is a difference between genetics and gene therapies. Gene therapy is a type of a therapy. Here we are talking about genetics knowledge, the knowledge around our DNA, to figure out what are the risk factors for us being more or less exposed to certain diseases. And what it means is that once we figure out what those are, we now know what are the biological mechanisms and pathways that put women into the risk for certain disorders. And then it's about the, coming up with different ways of how you deliver that therapeutic, whether it's a small molecule or whether it's a gene therapy, it doesn't really matter. So it's more around how can you use genetics to put a spotlight on potential novel mechanisms that are making ovaries age less or more quickly. So it's a slightly different angle than what your question was. But in terms of the data that we have, we about 2 years ago we published the first finding around the capabilities of showing that delaying menopause is possible. We've demonstrated this in mouse models, so this was not in human individuals. We showcased that by manipulating certain genes that we identified in humans, which are linked with later menopause, and we mimic that in mice model to see whether mice would also have longer and bigger ovarian reserve throughout their lifespan. We've showed the exact same phenotype as it was observed in humans. So these mice tend to have a longer reproductive lifespan by 25%. In human words, delayed menopause. And they also could respond better to certain hormonal stimulations during IVF processes, meaning that these genetic manipulations enable them to be more responsive, their ovaries to be more responsive to certain treatments, as well as to age less quickly than the wild type mice would. So there are evidence. We are at the very beginning of the journey, and we just have to science the hell out of those eggs to figure them out.
So one of the key aspects to look at in all this is regulatory agencies, because you may have great ideas in science, but if the FDA or the European Medical Agency or other agencies don't allow you to test them, you go nowhere to test them in humans. And we have to say that a lot of people think that menopause is just normal, and why should you fix menopause, right? So there's a lot of issues there. What Stasa mentioned before, which is important, is that there is a pathology of menopause, and that is early menopause. So you can intervene on women that have very, very early menopause or early menopause. Nobody thinks that is a great thing, and nobody thinks that is normal, right? So you can start looking at that. In our case, we did very well with the FDA, and we're now on phase 3 clinical trials for Fertilo, right? But for amino, for the product that relates to menopause, going back to your question on whether what have been the results on human, the answer is we don't know, because not a single human has received this treatment yet. And we're dealing with the regulatory agencies in order to see how we could do this. So it will be a phenomenal thing when we can try it on women, but we aren't there yet.
Yeah, so that's fascinating. So let's maybe deal with that transition into the clinic. When you're talking with regulators, obviously this is a very new area of science. What is their feedback? Is it something that they're open to? Is that something that you can see a regulatory pathway for? It's just a matter of time.
Well, regulatory agencies for medication, in my opinion, this is absolutely a personal opinion, are themselves in a tough spot, because let's look at the FDA in general, right? The mandate of the FDA is not to make people live better. And the mandate of the FDA is not even to cure people, which confuses a lot of those who study the subject. The mandate of the FDA is that nobody sells you anything that it's going to make your life considerably worse, right? That is the mandate of the FDA. So the FDA really doesn't win points if you live a healthier and longer life, but they certainly lose a lot of points if you take anything in order to achieve those objectives that makes you sick or you die or something really bad happens to you when you take. So there is an issue there, which sometimes I feel should be addressed in a different way, that Congress should change the mandate of the FDA, because I feel the FDA does the job that they are supposed to do, but sometimes this goes against the interest of patients, patient populations, especially in cases of, let's say, oncology, or in the case of Vitara, this company that I'm involved with that is developing a better incubator that acts like an artificial uterus. And so you get a premature baby and you put them in these artificial uterus. So it's not embryo into this thing, it's premature baby into this thing.
Mm-hmm.
And in those cases too, you have issues with the FDA, but sometimes you say, well, the alternative is death, right? Of the 23. But in the case of menopause, the alternative is not death. The alternative is inconvenience. And so you have to navigate through this carefully, balancing the safety of these with the convenience and the improvement of these. And you have to look at maybe cases that are at the edge, in which the menopause is very early, as Stasa was mentioning, and then you can intervene there. But it's not an obvious thing how to deal with regulatory agencies.
Yeah, understood. So it's something where at this particular juncture, it's difficult for you to get over the regulatory pathway. But in relation to your phase 3, presumably that is a case of how much money you have to be able to fund a phase 3 trial. And is this where big pharma is starting to get involved, or IPOs? I mean, how do you get into funding a phase 3 in this space?
Well, we're I think that we are the only induced pluripotent stem cell in phase 3, which is a great achievement of the scientist at Gamito. It's hard to explain in a few words how this process works, and I don't want to monopolize or bore the people who are watching us with all the details. But let's say it's not easy. It wasn't easy to get to phase 3. We were able to fund this through our investors, which we have some of the best VCs in the world. But it is a difficult thing. I mean, it's kind of juggling the science with the finance, with the regulatory. You kind of have to make it all work, and it's not that easy. But fortunately, it's been working very well for Fertilo, and the U.S. government has shown tremendous interest in menopause, because now women groups are finally raising their voice and are saying, look, there are aspects of our life that in a, let's say, male-dominated research field have never emerged, but now so many women are graduating and are taking leadership positions, like Stasa here with us, and they're saying, hey, what about our problems? What about the problems that are uniquely women's problems? And so the US government decided to want to be involved. And we've been working with the US government, with the FDA, quite successfully, I would say, because now finally the planets align between people caring about women's health, the science advancing, and I think we're making quite a bit of progress.
That's great to hear. And Stasa, of course, you're at the cutting edge of a lot of the science that's happening at the moment. So what are you seeing out there that's exciting you, either in your own work or perhaps other peers in this part of the sector?
Well, I think, maybe circling back to the previous conversation, I love to do that. Until 1993, women were not involved in clinical trials. So going back to Martin's comments that the planets are now finally aligning, that everyone is having interest in women's health, tells you that, we're just now in the right spot for making better science and finally starting to get more IP around female reproductive health. In terms of the kind of the most exciting bits, I would say is, as we mentioned before, the thing that we don't have in this space are our therapies, or we are at the very early stage of the journey around therapeutic development. So it's around getting and understanding better female body, whether that's genetics, whether that's microbiome, or whether those other technologies that are helping us figure out what are the kind of initiators of all these conditions. That's the first place. And then something that kind of overlaps very well with what we are developing at Cambridge, and what I'll be working on also in a commercial setting with what Martin and Gamido is doing, is developing models that better mimic female reproductive biology. The iPSCs and in vitro gametogenesis, that is a foundation of some of the work that Martin was also mentioning, is enabling us to develop in simple way 3D models of these ovarian cells, so that we can in one way utilize them to discover novel drugs, to do the screening of potential therapeutics, so we know what kind of impact they have on the female body or on the female ovarian system. And then the second one is producing eggs for women for different purposes. Obviously, for those two topics, we are at the different stages in terms of the readiness to these solutions to be implemented in the real world, but we're getting there. And maybe
And
the
what
sorry.
does the timescale? What does the timescale look like that, Stasa? So I mean, we're seeing now some of the longevity therapeutics coming through. They're going from phase 2 to phase 3, which is very exciting. But those companies have been at it for a long time, right? So
Yep.
I know we're in the foothills and this is early staging, but what do you feel are the timescales that we're working with?
I think we are at the multitasking stage. So we are pumping up all the old bits and pieces that are needed for the discovery. So we are getting more and more data. So we are getting better there. If you asked me this question about a year ago, most of the data sets that we worked on were from European women. Now we have a lot of data on women from African ancestry, Latin American ancestry, Asian ancestry, which is incredibly important because all these women have slightly different genetic regulators that are driving them to go through these diseases. So we're becoming more and more inclusive, which is incredibly important. And then in terms of the timelines, I feel like for the drug discovery, because these in vitro gametogenesis or cellular models don't necessarily need to be super well regulated and ethically proven, we can utilize them for kind of screening platforms, which I believe Gamido was advocating to do. But in terms of implementing them for actually producing eggs for women, I believe Martin will tell you better where they are with this. I believe we're still early on in the journey, because from the ethical perspective, we have a long way to go to figure out what's safe and what's not safe to be implanted back. And then finally, something that we haven't talked about is the prediction. At the moment in the clinical practice, there are some hormones that can tell you what your reproductive system looks like at the very moment. But they don't have long-term predictive capability. And why I believe that this diagnostic or predictive potential is actually very revolutionary for women is because it will give them power to make decisions. It will let them know, it will inform them that they don't have the capability to have kids at 36, 38, or whatever. So they have to start planning it earlier on. Current solutions don't provide that. They can tell you what's happening right now. But if you start capturing the decline in those hormones, it's usually, obviously not always, too late to react. But we need solutions that have long-term predictive capability. And this
That's
is
great.
something where with genetics, we are trying to put our hands in and provide better solutions that can be implemented very early on in the life, to kind of know way in advance and empower women to make these decisions.
Yeah, I mean that those biomarkers are providing an incredible trajectory for people to plan, and also the interventions that the likes of Gamito and others in the space will be offering. But I mean that's fascinating. And Martin, how about Gamito? Obviously, you mentioned that you raised the 33 million and another 10. So obviously you're capitalizing the business, and you mentioned that there are obviously the two aspects to it. What's next for Gamito?
Yeah, so we have to have let's say, an ability to receive patients at the right time. The average age of women who show up at the Prelude Clinic is 38, but it's kind of like not that relevant to know that average. You have to know the clinical history of each woman. And with the diagnostics that Stasa is working on, it would be very good knowing their genetics, and knowing that will give you more information than the AMH that she was referring as the standard diagnosis at the moment, but not in the whole journey, right? You would like to have, let's say, an AMH over 2, but you want to be able to predict more about the trajectory of the reproductive journey and the menopause journey, which is from reproductive age, perimenopause, and then menopause. So I think we're making tremendous progress in the first aspect of this, with fertility preservation, with the work that Gamito is doing. Also, Overture, another company that I'm involved with, that is working on robots, on robotizing embryology lab in order to achieve, for example, we made a robot that does ICSI, meaning injecting sperm in eggs, and babies have been born already out of this robot. So I'm quite involved with all the aspects of trying to achieve just one thing, which is to have a healthy baby when you're ready in life. But then there's life after fertility, which is longevity, health span, how to deal with menopause, and we want to focus on that too. We want to be able to help women throughout their ovarian aging.
Well said, Martin. But Stasa, before we wrap up, what about your experiences? Now you're in the marketplace, you're working on new science, you're capital raising and so on. Do you feel people are starting to get this now? Is the market starting to pick up and happen?
I think we have a mixed bag of responses. You would feel that some people are getting it because they have a personal experience, so they can reflect back on what they are, experiencing back home. But then you still have people saying, oh, it's just the 50% of the population. And, because we are at the very beginning of this journey, you always have to go with believers first. Like anything in life, I'm pretty sure Martin would agree on that, because these early believers would be the one, whether it's an investor or whether it's a clinician, they will be the one, advocating for your solutions and putting them on markets. So I think we are at the right time. I think we finally are starting to have good science that is worth of an IP. So stay tuned. As I said, science the hell out of those eggs, and we're going to get there one step at a time.
Well, that's a great note to wrap up on. So, Stasa and Martin, it's been an absolute joy speaking with you about this today, and thanks very much. Really appreciate it. It's been great.
Thank you, Phil.
No, thank you for having us here.